Yeah, we're looking for the number of hours we can rent the studio, right? That's the unknown part, right? So there's going to be a range of hours, exactly, right? So let's go ahead and set this up as H. That's our unknown. We want this to be the hours in the studio. Okay, so now let's think about what are our kind of like limitations? Right? What are we bounded by? Like, what is the minimum amount of money that I can spend? And what's the maximum? Right, so Mariana, 700, that's my maximum or my minimum? That's my max, right? So I know that $700, that's my max. So that's going to be kind of like off to the right of my inequality. What's my minimum? 400 is my minimum. So you see, I'm kind of sandwiched here in between 400 and 700. And so now I'm going to write the equation that allows me to decide how much money I can spend, right? So if I go into that studio, right, how much money do I have to pay no matter what? 225, right? Okay, so I have 225. And then on top of the 225, what do I need to pay? Exactly. I need to add $80, but per hour, what do I do here to represent that $80 fluctuates based on the amount of hours? Exactly. Right now we have 80 times H. So it's 225 plus 80 H. All right. Good. Right. So it's 80 per hour plus the 225, which is a flat fee. All right. All right. Now, let's find out what type of inequalities we're going to use, right? Because we could either include 400 or we can include 700 or not include them, all right? So where I say that I'm willing to spend his $400 savings, does that mean I'm willing to spend all 400? Can I include 400? I can, right? I'm willing to spend all of it, right? So then I can spend, right, exactly 400. I could spend more than 400 because the band is willing to put some money together, right? So whatever I spend, which is considered the 225 plus 80H, it can be greater than or equal to 400. Now, in terms of 700, can I spend more than 700? No, right? So whatever I spend, which is here, this is what I'm going to spend, it has to be less than 700. Exactly, right? And I can spend all 700. It didn't say that it had to be less than. If they put their money together, we have $700 to spend exactly, right? So it's less than or equal to, right? So I've sandwiched in my problem here. So if we kind of read this back, what we're saying is the amount of money I spend in the studio will be $225 flat plus $80 an hour. I can spend more than 400 or exactly 400, but I have to spend less than or equal to 700, right? So I'm kind of sandwiched in between. That's my limitations in terms of money. So then we use up the amount of hours that we think we need, right? And so that kind of gives us a range of how long we can be in the studio without overextending our time, all right? So now our job is just to solve this inequality to find out what is H, what are the possible hours, okay? So let's go ahead and solve, right? In this case, we would want to subtract 225 first from all three values. 400 minus 225, I believe that's 175. Let me double check. Yeah, we have 175, which will be less than or equal to 80H, which is less than or equal to, I believe this will be 475. Yeah. All right. So then to get H by itself, we would just divide all three sides by 80. All right. So we can bring down H less than or equal to 475 divided by 80 is, here we're going to have to I mean, we can use the exact decimal, but we can kind of round that off a little bit. I know I usually say not to do that. 5, this is the full total, 5.9375. Okay. And then the other value is 175 divided by 80, which would be 2.1875. Okay. So we're bounded by those hours, right? So we can do a little more than 2 hours, little less than 6 hours, right? And then that we would have enough money to pay for the studio plus the engineer, the sound engineer, in between those time frames. Okay. Questions on that? Here we go. All right. So for number 5, hopefully you've kind of had a chance to digest this one a little bit. So we have a girl, Crystal, here, who wants to figure out how many questions she needs to get right on the final to keep an A in the class, right? And that's often a pretty common question, right? Like, what do I need to do to get an A in the class? So I tell her she needs to score at least 70 points, but no more than 88, right? Each question is worth 4 points. On the day of the final, she shows up late, so she loses 8 points automatically from her test. Okay, so no matter what score she gets, I'm gonna have to deduct 8 points from it. Write an inequality that models the situation. Use it to find the range of questions that Crystal must get correct. All right, so our job here is to first of all write the inequality, and then we can then use it to find out how many questions she has to get right on this final. All right, so if we were to set something here as a variable, what do you think our variable should be defined as? Q for questions, right? That's a good one. And then why not more than 88? Because then that's at that point it's like overkill, right? It's like you don't really need to answer any more questions after that because you've already secured like enough points. All right, so then let's say I want to start a setup here. Okay, I want to start setting something up. What do you think would be my bound, my lower bound, my minimum value there that should be part of this inequality? Yeah, it's probably 70, right? So we have 70. What's going to be my upper bound? Yeah, we have 88, right? So I'm already kind of like building it with my bread, right? I got my bread. All right, now for her, right? How is she going to tally points? Well, we know it's 4 points per question. How do we explain that kind of like algebraically? Yeah, we have like 4Q, right? 4 points per question. So 4 times the number of questions that she gets right. So we have 4Q. All right. This is kind of like my meat, right? This is the inside part. Okay. So I know, hold on, I haven't drawn my inequalities yet, but I just kind of want to focus on the equation for now. 4Q is the amount of points you would get, right, by answering the questions correctly. But what happens to her that is going to have us make an adjustment to this equation? Yeah, we have to subtract 8 points from no matter what her score happens to be because she was late, right? So our equation is 4Q minus 8, right? So even if she answers all questions correctly, we still have to subtract 8 from that, and then that will determine what her score truly is. All right, so she actually has to score higher than what she thought she would because I'm going to subtract 8 points from her test. That makes sense? All right. So now let's go back and think of the inequalities. If it's at least 70 points, right? What kind of inequality should I use? Should I include 70 or not include 70? Yeah, I want to use equal to, right? Because I have to score at least, right? At least minimum. So I need to utilize it as that whatever score she gets, here we go. This is what score she will get. It has to be greater than or equal to 70. So then we draw the inequality this way. We could also do that. Yeah. It's another way to set it up. If you can see that kind of like that far ahead. And then for 88, right? No more than 88. What do you think? Can she score 88 exactly? Yeah, right. As long as no more than 88. Okay, so you can, yeah, set it equal to 88. So then the amount of points be less than or equal to 88, but it has to be greater than or equal to 70. So we're bounded between 70 and 88, right? So we're restricted between that. And now we can go ahead and figure out how many questions she'll have to answer correctly. So we can add 8 to both sides. And I think, Luis, this is what you were mentioning, right? You were kind of saying, like, couldn't you add 8 to figure out what she truly has to earn? And then this is kind of what it'll tell you. Right now, because she came in late, instead of having to earn a minimum of 70, she has to earn a minimum of 78. Because then if I subtract 8, right, she can still get those minimum 70 points. And then now if she wants to really get, like, aim for that, like, super A plus, right, as long as she doesn't have to go past like 96. So now we divide both sides by 4 here, and then this should help us out. So 78 divided by 4 would be 19.5. And then 96 divided by 4 is 24. So the highest she would get is 92. I mean, the upper bound is kind of, let me put it like this. You know you have to score at least 70 points, right? If you go past 88, it's like overkill, right? It's like way past it. So typically what you do in your head is like, okay, this is the bare minimum I need to do to pass. So as long as I do a couple extra just to make sure, I don't need to do like maybe the last 3 problems of the test. You know what I mean? That's the kind of thinking. So I was trying to make it as realistic as possible. But the highest she could get is like 100. I'm just telling her that she doesn't need to get more than 88 to keep the A. All right. So then what we have is this scenario, right, where she needs to answer at least 19 and a half questions correctly, and then no more than 24. So 19 and a half, you might think like, okay, well, that's 19 questions with a 4, and then maybe one with a partial credit of like 2 points, right? That could be a possibility, right? Since she was late, let's see, no, but since she was late, then the highest that she could get would be 96. Yeah. No, I'm sorry. The most that she could get would still be, yeah, I guess what you're saying. Yeah, she could, yeah, the highest she could get would be 92. That's right. So she gets 100, and then I subtract 8. Highest score she'd get would be a 92. I get what you're saying then. All right. So there it is. That's our interval. Okay. Questions on that one? So far, so good. All right. Okay, last one here. This one is for all my gamers out there, all my PS5 lovers. Here we go. Actually, I can leave it like this, I believe. Can you guys read it like that? Is that big enough? Should I zoom in a bit? All right. Is that better? I could do maybe a little bit more. All right, so we want G for games. Right, that's the unknown. Right, number of games, exactly, right? Number of games, video games. All right. Okay, so let's see what the setup could be, right? Maybe we can start thinking about what our bounds are, right? What is the minimum bound and what is the maximum bound? What's the least amount of money she's going to spend and what's the most amount of money she's willing to spend? What do you think? Yeah, we have a minimum amount of money she's going to be able to spend, which is the $200. That's our min. And then our maximum is the $400. All right. So before we think of inequalities, let's think about what's going to go inside that middle part. All right. If we're talking about each controller is $50 and every game is $60, but she's going to buy you 2 controllers, right? How much money is that already for her? Yeah, it's 100, right? It's $100 for 2 controllers. So we already know she's got $100 in here somewhere, right? As part of her equation. All right. Now she still has some. Obviously, she's going to have some money left over. So to that, we can add what? How much more money is she anticipating she'll spend? Yeah, it's the games, right? But how much money does each game cost? It's 60, right? So we have here that if we're trying to find out how much she will spend, yeah, it's 60G, right? So it's $100 for the 2 remotes plus $60 per game, right? What we're doing in the middle is the equation basically that's going to help her figure out how much money she will spend, right? So how she'll spend her money will be in this way: $100 set aside for controllers and then $60 for games. Right? We're assuming we live in a tax-free world right now, okay? So we're not going to consider tax. All right. Okay, so now let's think about what the inequalities should be, right? There's really no other pieces of information that we can use. So those $100 plus 60G, is that less than 400, less than or equal to 400? What does no more than mean to us? Yeah, less than or equal to, right? So she's willing to spend less than 400, but she's also willing to spend exactly up to 400. Okay. And then what about 200, right? She wants to spend at least 200, right? So she wants obviously to spend more than 200, but also she can spend exactly 200, right? So she, for whatever reason is like, I don't want to get him that much, at least 200, right? So exactly 200, right? Obviously more than 200, less than or equal to 400, right? So we're sandwiching in what she'll spend by the amounts of her original budget, right? Within her budget, there's $100 set aside specifically for controllers, okay? So she's buying you 2, right? So that's where the $100 comes from, okay? All right. So then let me erase this. Let's go ahead and solve. Let's figure out how many games you're getting. So we'll subtract 100 from all 3 sides, right? So what is this doing? This is basically saying like, okay, from whatever she was going to spend on you, she bought those 2 controllers. So now like $100 is gone from her budget. So what's left in her budget willing to spend? She's got about $100 minimum up to about 300, right? So by buying you those two controllers, now she's gone from like a 200 to 400 down to 100 to 300, willing to spend on just games. All right. So let's see how many games that'll get you. Right. So if you divide by 60, G will be less than or equal to 5. All right. 30 divided by 60 is 5. And then on this end, we're looking at 100 divided by 60. So 1.66, which is not really possible, right? You can't buy 0.66 of a game. So essentially, what's the minimum amount of games that your grandma could get you? Man, she can't get you one, because one is not like, she would be below her budget on that. The G, the amount of games, has to be between 1.66 and 5. So 1 is outside of that bounds. Right? So anywhere between, typically, mostly like between 2 and 5. Right? She can get you 2, 3, 4, or 5 games.